When our model is done training, we can go in and run validation on top of it as well. It's basically just measuring how good is the model performing when we want to generalize it across the task and the data that we're training our models on. There's a very important step of the computer vision update takes instant segmentation, just the training pipeline, because this is how good our model performs. So in this video here, we're going to talk about how we can convert the validation results and also the confusion matrix into different formats. So we have CSV, HTML, JSON, SQL, all these different formats here. So this is very important if you want to take the results, export them out. We're going to talk about what is the confusion matrix, but also some other validation results. So let's just jump straight into the Ultralytics documentation here. We also have a notebook where we're going to run through some examples, see the code and all that. You can go in and grab it directly from the GitHub repository as well. But if you go in and take a look at it, we have all the different tasks here. So the first mode that we have is train, then we have validation, prediction for inference, then export it and do tracking and benchmarking as well directly. So it's just a single command that we need to run with our data and also with our model, and it's going to do all of it automatically with Ultralytics. So we already have a ton of videos covering like the full pipeline, how you can train it, validate it, and everything. So one of the reasons why we should use Ultralytics for doing validation on the YOLO models is because it's just so easy. It's just a single command. We get all the precision, like the different metrics, the mean error positions, evaluation of our home model. It's just convenient. So it's just a built-in feature, single command that you need to run, flexibility, and also you can use it for hyperparameter tuning. So if we scroll a bit further down, we can see an example here. We're going to run through the code in just a second, but if you then just call model.val, dataset and settings and everything that you have trained your model on will be remembered. So it's going to use that under the hood, the specific dataset that it was trained on, but also all the settings, high parameters, model parameters, and all of that. So you just need to load in your model, call the eval.eval, and you will be able to extract all the metrics. We have a few different arguments here that you can throw into your model evaluation or validation. It's very similar to what you do if you run inference or training and so on. So if you want to use half precision, the device you want to run it on, batch size, image size, the specific data that you want to validate it on, could even be that you want to validate it on data that you haven't trained on or not a specific training data set. You know that you split it into three. So we have your train, test, and validation split, but could be that you want to validate the model on a completely different data set, or maybe new data that you have generated after the model has already been trained. So if you scroll a bit further down, we can see we have these different examples, and now we have these methods that we can call on top of our results to export them into different formats. Because a very good thing that we get out as well is the confusion matrix, both after training, when we do validation and all that. And this is very important because it tells us how well is our model performing. We want to have all the values in the diagonal for our confusion matrix. So this is the documentation. You can go and take a look at it. If you jump inside the Ultralytics notebook repository, we have all the notebooks covering pretty much everything. Very good documentation. You can go through them step by step. Just open it up, run them, even free GPU resources inside Google Colab. So if you just take a look at it, we have all the documentation, all the notebooks, how to count objects, how to export the validation results, how to generate heat maps. All these things here, you can use them out of the box with Ultralytics, and they're already formatted into a Google Colab notebook, and we have covered them in pretty much most of the videos here on the YouTube channel. So now I'm just going to open this in Google Colab. Very nice to just use in any browser. We can go ahead and use the hardware acceleration. I'll just zoom in out here a bit. But if you go inside the runtime, change runtime type, we can set it on at GPU. We're not really going to do something crazy in this video here, so let's just go with a smaller GPU, a T4. We can connect to it. If you want to train, you can take a larger GPU, but even just the 3 GPUs in here, you can easily train the Ultralytics YOLO models in maybe an hour, 2 hours. There we go. We're now connected to our runtime with our GPU support. The only thing that we have to do pretty much in whatever environment that you're working is pip install Ultralytics, and they will take care of the rest. So I'm just going to run this notebook, pip install Ultralytics, we import it, and we run the Ultralytics checks. If there's dependencies not installed already, it will take care of all that. Even if you have CUDA available in your environment, it's gonna install everything with CUDA as well. So we can see here that it's collecting some NVIDIA CUDA stuff, CUDA 12. It will just take a few minutes here, maybe 30 seconds. So once that is done, we can import the YOLO class from Ultralytics, then we can create an instance of our model. If you just specify the models directly from the website out of the box, it's going to download automatically if it's not already in your path where you create this instance of the YOLO model. If you have a custom fine-tuned model, you can just swap out the path here. It's going to load this in, and again, it remembers the dataset that has been trained on. If you do it on your own custom model, all the configuration settings and all that. So after we have loaded in our model, we can use our validation. We specify the Cocoa 8 dataset, so just a very small subset of the Cocoa with eight images. And we set verbose equal to true, so we just get as much debugging and results out in the terminal as possible. So I think it should be installed up here now. It's still installing the last bits. After that, we can run this block of code and we'll get our validation. We can then go in and export it to the different formats. So it's really good to have the notebooks, have the Python scripts that you're working with, and then also the Ultralytics documentation on the sideline, because then you can just directly go in and see what is possible to do in here, what are the different arguments, command lines, because the code itself is just a few lines of code that you need to run. The default parameters are very good, but if you want to do some custom stuff, we need to know these different arguments that we can set, and it's actually a lot. So if you scroll a bit further down, we can see to DM, to CSV, to HTML, to JSON, and we can also even export it to SQL. Let's go back here. Let's see if we have installed it. There we go. It's now installed. We ran the validation. So we can see that it didn't find the dataset path, so it's automatically going to download it as well. Now we get our validation results here. So we can see we have 4 images here. We have 4 person. We have 1 dog, 1 horse, 1 elephant, and 1 umbrella. We see the precision, the recall, mean error precision. So if you just want to take a quick look at how does our model perform, this is giving you a very good idea. So the mean error precision is just how good is it act like at finding the objects across all the different classes here, or here we have separated into classes, but this is the overall mean errors precision. So this model here does pretty good on this small data set here. We have the recall, so how many detections are we missing, and how many detections are we actually getting correct here in the precision. So these two values, all the values should pretty much go towards 1. The closer they are to 1, the better. So if you have a low recall, you might miss objects, so that might not be good. You have high precision because it gets all the objects, but it might miss some objects that it should have gotten if you have low recall. So make sure to take all these into account. We can also see that the results has been saved into our runs directory, just as if we're training the model. So now we have our runs detect. We have a validation. If you run prediction or train, you will have a folder for that as well. So now we have all the results here. We have the F1 curve. This is also good precision recall curve. So again, we want these to go towards 1. So ideally it should be all the way up here. We have all the classes, and we also have the precision recall curve for each of the individual classes. This is very important if you work with multiple classes at the same time. The other thing that we want to talk about is the confusion matrix. So this is basically just all the predictions and the ground truth labels. As you can see here, ideally we want to have all the values in the diagonal because we have the ground truth on the x-axis and the predicted values on the y-axis. So for example here, let's say we have horse. So here we have a ground truth. The horse is down here at the bottom, so that corresponds with the prediction that we got. So for a confusion matrix, it depends on how many classes we have and all that. We can even go in and see a validation path. So how good does it perform on the predictions? So for example, here we can see that this is actually like the predictions that we're getting from a validation set. We have some people walking around here. We have 2 horses. We have a horse. We have a person, umbrella, elephant, and so on. This is all the validation results that we get out. The next step here is to go in and export the validation result into a Pandas DataFrame. Could be that you want to work with it, your data science team wants to work with it. Also, just if you want to make custom visualizations and all that, it's going to be much easier if you have it into like a structured format that you can load into whatever other framework or library. So if you just run this one here, we're going to get the same results where we have the precision recall, F1 score, mean error precision, all instances. It's just in the Pandas DataFrame format. We can do the exact same thing here with our CSV format. The only difference here is that it's going to save it as well. So validation results CSV, or it's actually going to load it because it's already saved here in the validations. This is the CSV format. We have SQL. Resolve save to equals results in results database. So now we can see that it has converted into a SQL-lite database. This is just a very lightweight database. You can use the exact same for Postgres or whatever, like any relational database that you can use, MySQL, Postgres, and so on. All of it works. If you want to use this, you can open the SQL viewer and basically just upload this results to database file. It's just going to be a table format, exactly in the same way as you remember, like Excel, Sheets, even just the CSV format. So it's just going to create a table in our database, and then it's going to put the validation result in there. There's also other different export formats. I might prefer maybe JSON a bit more, because it's, if you want to have an API where you want to get your validation metrics, it's easy to just have it in JSON format. So you have an endpoint, you do the training, you do the validation, you send the validation results back with the JSON structure. So that is a very good example too. We have the HTML, XML, JSON. You get all the format here. So it's just different ways of structuring your data depending on the use case, what you want to use the results on. You want to use it with endpoints, APIs. You want to do other visualizations, maybe some other analytics on top of your data with Pandas. So these are all the different examples available. So this is the confusion matrix export that you can do as well. So we have this confusion matrix in a CSV file. You can load that in. You can export to SQL, so all the other formats here that we have as well. So not only just all the results, but also the confusion matrix itself. So metrics.confusion matrix to DataFrame. Here we export it into CSV format. And that's pretty much it. Result has been saved to the table results in our results database. So this is even connecting it together with your database. You can have endpoints with the JSON responses and all of that. Here we have the confusion matrix CSV file. We have the HTML file. We have the JSON file and all that. If you open this one up, there we go. We have our CSV file. This will just be the table inside our database as well. It's just a different way of storing it. So here we have all the results. And if we load them, visualize it, we will have all the values in the diagonal for the correct predictions. So this is very useful if you want to use Ultralytics for training, export the results, use them somewhere else in your pipeline, do more analytics that we're not supporting in here. Very important to know in just a few clicks, few commands that you need to run. Make sure that you know all the different arguments, both when you're doing training, validation, prediction, and all of that. Hope you learned a ton. Hope to see you guys in one of the upcoming videos. Until then, happy validating.